Hi, I'm Mr. Underwood, and I'm going to go through a few questions revising for your key assessment task coming up. I'm going to go through a few. So let's get started. Mainly what I'm going to focus on though, basic skills, things such as your index laws and things. They're just really leading up to these. So of course I'm just going to go through sort of a few questions. We've got this sort of one here. We've got simplifying logs, solving for x, solving equations. I'm going to go through more solving log equations. And of course, then we're going to look at sketching the graphs, describing the transformations, stating domain and range, finding the rule for the inverse, sketching the inverse, and so on. So look, this sort of will cover most of the skills that you'll need to do well in your KAT, and but of course certainly not everything. All right, so away we go. Let's have a look at this question. First of all, whenever you're looking at something like this, you need to know your perfect squares, and your perfect cubes, and so on. And you usually get a hint from the question, well, if I've got a 3 here and a 9 here, it's probably fair to say that we want to express this 9 as 3 to the power of something. And you would probably say you would be doing this to the same over here. Now, as it turns out, I know that 3 to the power of 4 is equal to 81, and 3 to the power of 5, therefore, is equal to 243. Now, you may not realise that, but by doing these questions and by having a look at these powers, it usually gives you the hint that we're looking at 3 anyway. Otherwise, it's going to be pretty hard to simplify. So let's start with this question. First of all, we've got 3 to the power of 2x minus 1, and we're looking to solve this expression. Times, well, 3, 9 is the same as 3. So I'm going to do that in brackets, 3 squared to the power of x equal to, as we discussed, 3 to the power of 5 is equal to 243. All right, now let's expand that out. We've got 3 to the power of 2x minus 1 times 3 to the power of 2x using one of your index laws, and is equal to 3 to the power of 5. Now, when we're multiplying things of the same base, we can now add the powers. So we've got 3 to the power of 4x minus 1 is equal to 3 to the power of 5. Given left-hand side must now equal right-hand side, therefore we don't really care about these because this 4x minus 1 has to equal 5. So therefore, we could say 4x minus 1 is equal to 5. Rearranging, I'm going to say that 4x equals 6, therefore x is equal to simplified fraction, 6 over 4 is 3 over 2. Okay, so the hint with doing these questions is, first of all, whenever you have these, look for, for example, the hint was 243 is equal to 3 to the power of 5, and if you didn't realise it, you'd probably sort of have a look at this one here, and you would say, well, okay, it's quite easy, 3 squared is 9, and we simplify it that way. So that usually is the hint that we're looking at the base of 3 to the power of something to simplify even further. Okay, I'm going to go through these pretty quick. First of all, let's sort of keep the left-hand side. We're solving for x, but let's simplify the right-hand side. So first of all, you need one of your laws is we've got our log law, which is m log a to b is equal to log a b to the power of n. So we've got to do the power law in reverse over here. That's what we're going to start with. So therefore, we're saying that we've got log 10 of x on the left-hand side. 10x is equal to log to the 10 of 36 to the power of a half. Well, 36 to the power of a half is the square root of 36, which is 6. Minus, let's apply that rule again, log 10 to the 3, and that's 3 squared. Okay, so let's leave the left-hand side as it is. log to the 10 6. Oops, that's log to the 10. That's, can't forget that. Log to the 10 6. Take away log to the 10 3 squared. Using your log laws, that's going to be log to the 10 of 6 over 9. Okay, is of course equal to log 10 of x. And once again, therefore, we've got, if this expression was to be true, therefore we can say that x is equal to 6 over 9, or 2 over 2/3. Okay, let's have a look at another one. Solve the following equation. Well, first of all, we have to use our log laws. Now remember, our log laws are if we're adding two things of the same, we've got the same base here, then we can then multiply them together. So we've got log to the base 10 of x times 2x is 2x squared minus log to the base 10 of x plus 1 is equal to 0. Well, our log law over here, we can combine those two now. But this time we have this as our numerator and this is our denominator, which is 2x squared over x plus 1. Alright, like that is equal to 0. Now, what we have to do is we need to solve for x. So what we have to do is we need to cancel out this log somehow. Well, what's the inverse to a log? It's the exponent. So what we need to do is technically what we're doing is 10 log to the base 10, and they're going to cancel each other out, of 2x squared, x plus 1, is equal to 10 to the power of 0. And anything to the power of 0, one of your index laws, is equal to 1. So what we've got so far is we've got 2x squared over x plus 1 is equal to 1. All right, let's go ahead and we need to rearrange. I'm sort of running out of room here, but we've got 2x squared is equal to, just cross multiplying, x plus 1, and then I'm going to get this all on the same side. I'm going to have 2x squared minus x minus 1 is equal to 0. Now we can look to factorise, and but at the same time, if you can't factorise, we can always solve this using the quadratic equation. I'm just going to pretend that we can't factorise this, and we're going to just go straight to the quadratic equation. All right, so there's two methods. I guess if you were doing, trying to look for factorising, you would have this 2x, and you would have an x here. And when we can, of course, sort of by observation, sort of fill in the blanks. Now, let's think about it. If I had a plus 1 over here, and I had a minus 1 over here, let's have a look and see how that would play out. I've got 2x times x is 2x squared. 2x minus 1 is minus 2x plus x is, so there you go, we've done it, just by observation. So that's the hint. Whenever you've got something like this, and you sort of go, oh, I've got this coefficient of x squared, which is not 1, it's something else, that's probably the best method in which, if it's factorised, if it can be factorised, it's probably the best method. Because we know that this constant minus 1 has to be equivalent to these two things multiplied by each other. So really we just have to sort of mix them around and do a little bit of trial and error. That's probably the easiest way. So I've factorised this, which means that saved me all of that hassle of doing the quadratic equation. So therefore x is equal to, using our null factor law, minus a half, and x is equal to, also is equal to 1. All right, we could have got the exact same thing, quadratic equation, but it would have taken longer. All right, so let's have a look at this one now. Given that this expression here, find Q. All right, well, this is no different and it's no harder, but the problem is you see all of these sort of expressions and you sort of don't know where to start. Well, first of all, we've got to do the reverse of the power law. So what we have to do is, you should know that this, let's look at this expression here, that's the same as log to the base log to the base cube, it looks a bit confusing, of 3 to the power of 4, which we discussed before, plus log to the base cube of 2 squared, which is 4, minus log to the base cube of 144 is equal to 2. Okay, let's apply our log laws on the left-hand side. 81 times 4 is 324. So I've got log to the base cube of 324. And of course, then I'm going to apply this rule here, which means we're dividing that by 144. Equal to 2. Okay, so what we need to do now is we need to simplify this. It says find Q. Well, what we need to do is we need to find Q. How do we do that? Well, what we need to do is we need to do the opposite or the inverse of this. Remember, let's just assume we don't have a calculator. Q to the power of log Q, 324 on 144, is equal to Q squared. Okay, so therefore, on the left-hand side, this just cancels out, and what we have is we have 324 over 144 is equal to Q squared. All right, so, and then I can do the square root of both. Q is equal to the square root. I don't have a calculator on me. I'm just going to leave it. I know it can be simplified, but you get the idea. All right, so once again, just applying our log laws, and expect quite a few of these in your assessment. Let's try this one. We're solving for x, much the same. This time applying our rules. Well, first of all, we've got just the 1 on the left-hand side, but remember, this is the important thing. Until this 3, until we do the reverse power, then we can't actually apply those log laws. So, for example, if I have log to the base 10 of x plus log to the base 10 of, 2 log to the base 10 of x squared, that does not equal log to the, that does not equal 2 log to the base 10 of x cubed. Okay? What we have to do is we have to apply this law in here. So we've got log to the base, let's get log to the base 5 of x minus 1 to the power of 3 minus log to the base 5 x squared minus 1 is equal to log to the base 5 of 125. Okay, now we can apply our log laws, and we will do so. Log to the base 5 of x minus 1 all cubed over x squared minus 1 is equal to log to the base 5 of 125. Okay, now as it turns out, log to the base 5 of 125, if you like, is, we could say that log to the base 5 of 5 cubed, but given the fact that we've got an expression on the left-hand side, we can say that this must therefore be equal to this. So therefore, I'm going to say that x minus 1 all cubed is equal to 120 over x squared minus 1. Well, we could actually do x minus 1, x plus 1, that's equal to 125. that's at least going to cancel out something. This is going to cancel out. We're going to have x plus 1 squared on top over x plus 1 equals 125. Okay, so we can go from here, and I'm going to expand, and I'm going to now say that that's x minus x minus x is minus 2x plus 1 is equal to 125x plus 125. All right, let's get ahead and let's rearrange. I've got x squared minus 127x minus 124 is equal to 0. And from there, we could then go ahead and it's saying solve for x. We can look to factorize first. Is there a number two numbers that multiply to give negative 124? And that to give what, 127? Well, I don't know. But nevertheless, I'm going to let you finish that off yourself with a calculator. All right, because I wanted to get into this. Consider the graph. This is, I think, the most important stuff and the stuff that some students really struggle on. Describing transformations, sketching graphs. All right, as I said, it's the process. We want to repeat the same process, doesn't matter what graph. We want to, first of all, my method was looking, first of all, at the, look at the reflections. Okay, look at the reflections. Then look at the dilations. And then look at the translations. And a lot of the time you can sort of look at these at the same time. Okay, we can have a reflection in the y-axis and a dilation in the y-axis of so many units. So, describe the transformation. First of all, let's talk about this. How do I go from this graph of y equals log to the base 2 of x? How do I go from this to the transformations? Well, first of all, we've got our base form of log x, all right, looks something like this. Okay, and this point there is 1, 0. And the first thing we want to look at is the reflection. Let's have a look at the reflection. So if I was to go from log to the base 2x, if I was to go from log to the base 2x to negative log to the base 2x, let's look at just one reflection. What is that? What's happening? Well, first of all, it's a reflection. We're going from this to this. It's a reflection in the, what are we reflecting at? Reflection in the x-axis. So, so we've got a reflection in the x-axis. Okay, now that's going to cover this negative guy here. Now what we're going to do is we've got a dilation. We've got a dilation of 2 units parallel to the x-axis. What that this 2 is doing is multiplying all of those y values by 2, which means that it's a dilation of 2 units in the parallel to the x-axis. All right, we've looked at the reflection and dilation in the x-axis. Let's look at the same for the y-axis. All right, so therefore we've got a reflection this time. Our graph is going from, it started off like this, it then looks like this, and now we've reflected that in the y-axis. So we've got a reflection in the y-axis. Now, that's actually covering the fact that we've got this negative x here. Now, the question is there a dilation in the y? No, this isn't a positive value. This isn't we've got a coefficient of 1 there, so no. So we move on, and now let's look at our translations. We've got, well, for this to be equal to 0, 2 minus x equals 0. what does x have to equal? Well, x would have to equal 2. So therefore, we've actually moved that across 2 units to the right. Okay, so translation, 2 units to the right. And then lastly, I won't write it down, I'm sort of in a hurry. The last one is the translation of 4 units up. Now it says here sketch the graph. Now, given what that's saying, is let's sketch this and let's sketch this in stages. Let's sketch first, I'm going to combine the first two together. I'm going to sketch the graph of minus 2 log to the base 10 of x. Well, first of all, we go from this graph here with the point, and that's an asymptote at x equals 0, this point of 1, 0. And what we're doing is we're multiplying every y value essentially by 2, and then we're inverting it. So we're not, none of these, this point here isn't actually going to change. So, first of all, this is our graph of log to the base 10 of x, log to the 2 to the base log 10 of x, and then if we're reflecting in the y-axis, that's going to look something like this. And that point's still 1, 0. Okay, let's look at the next one. Let's look at the reflection. I'm going to go from now, I'm going to be sketching the graph of minus 2 log to the base 10 of minus x. Well, now all of a sudden we've reflected this in the y-axis, which means that this point here is now negative 1, 0. All right, very messy, I know. It's really hard to do this on my computer. All right, now what we're going to do now is we're going to sketch the next one, which is we're going to look at one of the translations. Let's look at this translation in here. We're moving it across 2 units to the right, which means that suddenly this asymptote has moved from x equals 0 to x equals 2. And this point here, negative 1, 0, has now moved across 2, which is 1, 0. Okay, and this is x equals 2. This is a terrible shape, by the way. And this is the point that crosses the x-axis at 1, 0. And finally, I'm going to sketch the graph altogether. Minus 2 log 10 of, so that was of 2 minus x. 2 minus x, we've already done before, plus 4 is moving that up 4. Now, what's that going to do? It's going to change this y-intercept. No longer, or this point, 1, 0, actually will become 1, 4, and that's going to be pretty useful for us. We're going to have to find the x and the y-intercepts. So, how do I find the x-intercept? Well, first of all, x-intercept, I'm going to let y equal 0. To let y equal 0, we're going to have, what's our original function again? I'm going to have 0 is equal to minus 2 log to the base 10. Was it log to the base 2? Sorry, log to the base 2. Log to the base 2 of 2 minus x plus 4. Very ugly. I'm running out of room here. All right, so what we need to do now is let's get everything over. I've got minus 4. I've got therefore minus 4 is equal to minus 2 log to the base 2 of 2 minus x. I'm going to divide both sides by minus 2, which is going to give me 2 is equal to log to the base 2 of 2 minus x. Now, I've got to solve for x. So what I need to do is I need to do the opposite. So the opposite to log is an exponent. So we've got 2 squared is equal to 2 to the power of log 2. It's just going to cancel each other out. It's 2 to the power of minus, well, I've got 2 minus x. Let's get x on the other side. I've got x is equal to 2 minus 2 squared, or 2 minus 4, which is minus 2. So, what we now have is our graph as our x-intercept is -2, which we fraction 2 units to the right. So this graph here is suddenly looking not the best shape, is it? Okay, so at the end, it's looking like our graph is going to look like this shape. Okay, and this point here is -2. And then do the same for the y-intercept. Y-intercepts tend to be easier because y-intercept let x equal 0. Okay, I've got therefore -2 log to the base 2 of 2. Anything to the, so that's the same as -2 plus 4 is 2. So y-intercept is 2. So, this is messy. So our final graph is going to look like this. First of all, we've got this point -2. We've got -4. We've got a horizontal asymptote at x equals -2. The graph was much steeper than we thought, and it's actually sort of tracking through this point here and looking something like that. All right, now it says here to sketch the graph of y stating the domain and range. Now, stating the domain and range. And why do we have to do this? Well, if we're applying the inverse, it makes it much easier. The domain is the element of from negative infinity to -2 not inclusive. All right, and then the range doesn't look like it here, but it's a real number. Now it says find a rule for the inverse and sketch the inverse. Well, for starters, just a hint, when you're sketching the inverse, we actually invert these coordinates. So this coordinate of -2, 0 will actually become, for the inverse, 0 -2, like so. And this point here, this key point here of -0 -4, would actually become -4, 0 for the inverse. So you can go ahead and sketch the inverse if you like, but I'm telling you that this is a reflection on the graph y equals x. Okay, y equals x. So as it turns out, -4, 0. All right. So as it turns out that we've actually got this, what's it going to do? Well, I guess you've got to have to join these points up. But you would assume, and if you can't get that, let's actually find the rule for the inverse. So what do we do? Well, first of all, to find the rule for the inverse, let's write this out. We need to swap the x and y. So what do? We go ahead and so we've got swap x and y. So I've got x is equal to -2 log to the base 2 of 2 minus y plus 4. And I need to solve for y. So that's x minus 4 is equal to minus 2. Okay, and divide both sides by minus 2 is equal to the base 2. Do the inverse both sides. I'm going to have 2 to the power of x y, and therefore I'm going to say y is equal to. You're going to probably get something easier than this on a CAT, but that's our expression. We can, of course, simplify that if you like to, what's that, 2, this power is 2 minus x over 2, if you like, but we can then go ahead and sketch that. Now, what is the shape of that graph? Now, we know that these key points, but the shape of that graph, if I was to be looking over here, if I had a 2 to the power of x graph, I know that that's going to look something like this. If I had a negative 2 to the power of x graph, then that's going to look negative 2 to the power of x, and that's going to look something like this. And if I had I've actually got a 2 minus x graph, so what's that going to look like? I've got minus 2 to the power of minus x. That's going to look like, well, we've got to reflect this graph in the x-axis. So suddenly that's going to, what are we looking at? We're going to reflect that, so it's going to look like something like this. So when we get over to here, okay, so just a quick thing, this point here was actually 2, y equals 2. So over here, we now have this, shape, and our graph was looking like, so our graph had that shape, but this point is actually 2. Like over here, 2. Alright, and then this point. Alright, and so what we have in the end was the asymptote here, very messy, y equals 2, and our graph would cut here, here, like so. And you can see that that is a reflection of this graph, y equals x, so that's what the inverse is. All right, now in the next example, I'm going to stop there, and in the next video, I'm going to do the same thing, but this time for an exponential graph here. So I'll see you then.